This is Mr. Beck Does Your Homework. This is homework 16, questions 10 and 11. It says, an archer puts a .26 kilogram arrow to the bowstring. An average force of 223.3 newtons is exerted to draw the string back 1.28 meters. So we know that when I'm pulling on a spring, the force over the distance actually goes up and up and up and up and up. But what they're telling me is what the average force is. So it's going to be the average of the top and the bottom. So that's my average force. So if I'm going to want the area here, it's going to be the same as the area of that triangle that I would normally get. So the work is going to be the same. So I can just do my work is going to be my average force times my distance. So that's easy enough to do because they give me the average force. So with what speed does the arrow leave the bow? So now I know that I did this much work, and when it releases, then this bow is going to send that arrow flying out this way, and that arrow will have all the energy that used to be stored in the spring, stored in the bow. So if this is how much work I did, that is going to equal how much kinetic energy the arrow has. So I've got average force times distance, so that is 223.3 is my force. My distance is 1.28 meters. That's how much work I did pulling back the bow. That's how much energy is stored in that spring, and that's how much energy will wind up being my kinetic energy, which is 1/2 mv squared. My mass of the arrow is 0.26 kilograms. So this is 223.3 times 1.28 equals 1/2 of 0.26 kilograms times v squared, and that's enough to do some algebra and solve for v. Number 11 says, if the arrow is shot straight up, how high does it rise? Well, again, I've got this work being force times distance, so this same amount of energy, in this case, if I shoot it straight up, so if I send that arrow flying straight up in the air, then it's going to have some PE when it gets way up as high as it'll go. So for the second part, I know that my force times distance is going to equal my potential energy due to gravity. So I've got 223.3 times 1.28. That's how much work I did putting energy into the spring. Well, when that happens, that's going to release, and it's going to send it up such that it'll go to a certain height. So I'm going to get mgh here, which is 0.26 times the acceleration of gravity, which is 9.8, times the height that I'm looking for. So I know this and this and this and this, divide by those, and I will get my height of how high it will go because energy is conserved.